Hi, welcome to the class. Today we'll do another topic of chapter sound, and the name of the topic is resonance. Now, resonance, in the last class we discussed about three types of vibrations: free, damped, and forced. So now resonance is a special case of forced vibration. Now, let me tell you something which is very important for us to understand. Let us say this is a pendulum, and now the bob of the pendulum is being displaced. It is being displaced. It is not forced. So it is taken up till this point and then it is displaced. It is released. So when it is released, the bob of the pendulum will oscillate on its own. I am not doing anything. What I did, I took the pendulum up till this point and I released it. Once I release it, what will happen? It will oscillate on its own. So the frequency of the pendulum right now when it's oscillating on its own is known as natural frequency. So this is what we call natural frequency. So this is the natural frequency of this bob when it is oscillating on its own without the presence of any external force. So there is no external force applied, we just displaced it, we just released the bob from its mean position. Okay, so when you release it, you're not applying any force, you're just releasing it. Like I took this marker and I released it. So when I release it, what will happen? I'm not throwing it downwards, I'm just releasing it. Once you release it, what will happen? It will fall under the effect of gravity itself. In a similar way, when you displace it from its mean position and you release it, you're not applying any force, you're just releasing it. Vibrations of the body will take place in the absence of any external force, and these vibrations, they have some frequency, and that frequency is known as natural frequency. So natural frequency in the absence of any external force. Now when I apply some external force is also going to have some frequency. External force is also going to have some frequency. So released, natural frequency, absence of external force, you apply some external force is also going to have some frequency. Now that frequency is not is going to, we are going to call it, you can call it forced frequency or something like that. Okay, so natural frequency, and then we have this forced frequency. So what happens in resonance, the frequency of the external force, that is the force frequency, if the frequency of the external force matches the natural frequency, it means the frequency of external force. So when this happens, frequency of external force equals natural frequency of the body, this is what we call resonance. So this phenomena is known as resonance. So what resonance is? Resonance is a special case of forced vibrations, because now we started applying external force on a body, and if the frequency of external force equals the natural frequency of the body, this phenomenon is known as resonance. Alright, so this is resonance, and this is a very important condition for resonance. So if you write the definition of resonance, what you are going to write? Resonance is a phenomena in which the frequency of externally applied force matches or equals the natural frequency of the body, and when this happens, amplitude of the body is going to be maximum. Amplitude becomes maximum when this takes place. So when frequency of externally applied force equals the natural frequency of the body, amplitude of the body becomes maximum. So this is what we call resonance. Okay, so this is resonance. Now let us discuss some examples of resonance. So the very first example which I would like to discuss with you is pendulum. So question also comes from this, and the very first example is, suppose you tie 3-4 pendulum of different length, one of this thing, the other one of this length, the third one of equal to this length, and then fourth one, let us take this one. Okay, now what we do, we displaced from its mean position and we released it. So what is going to happen when you released it? It is going to vibrate. The vibrations are going to travel through this rod, and then it is also going to vibrate. Okay, now you know that in a pendulum the frequency depends on the length. The frequency depends on the length. So what happens is, the vibrations are going to travel through this rod, and then this pendulum will also vibrate, this will also vibrate, and this will also vibrate. But what you will notice is this, that this pendulum and this pendulum will start vibrating with a rhythm. They will follow a rhythm. And why this is happening? Because the length of these two pendulums are equal, and the frequency of vibration depends on this length. Now since the length is equal, the frequency will be equal, and when the frequency of these two vibrations will be equal, you know resonance will happen. And when resonance will take place, they will move in a rhythm forward and backward, and that time the amplitude of these two pendulum will be equal. Okay, so this is the first example. Second example is when you're driving a bike or a car, and there is a nut which is loosened in the part of any bike or any car. So what happens is, when you don't shift your gears, when you drive for long in a single gear, what happens is there will be some vibrations which are produced. Okay, because you are driving in a single gear, and when that vibration matches the vibration of this nut, so that nut might come out. So this is again what happens. The vibration of the vibrations which are taking place in the car or bike, because you're not changing the gear, that vibration matches the natural frequency of the nut, and if that happens, resonance will take place. The amplitude of vibrations will become maximum, and the nut, there is a possibility that nut might come out. Okay, so this is the second. Third example is when soldiers, they're marching and they're crossing a bridge. They're asked to cut off their march. It means they're asked to stop the marching, and they walk normally through the bridge, and then again they resume their marching. Why this is done? Because again the same thing happens. The frequency of the marching may match the natural frequency of the bridge. So frequency of external force, that is the marching of the soldiers, may match the natural frequency of the bridge, and if this happens, the bridge is going to vibrate with the maximum amplitude, and if this happens, then there is a possibility that bridge might break. So that is why they are asked to stop marching when they are marching through a bridge. So this is the third example. Now the fourth one is your radio. When you want to match a certain frequency with a radio station, what happens is, suppose the radio station's frequency is 90 megahertz, just to give you an example, and you are turning, or you are changing the frequency of your radio. So when you make it 90 megahertz, so that is the forced frequency for your radio. Okay, so if this forced frequency of your radio matches the natural frequency of this radio station, they both will come in resonance. Amplitude will be maximum, and you can hear out loud music or any telecast which is happening on this radio station. So these are the four examples of resonance. I hope this topic is clear. Very important topic, and it's a special case of forced vibration. Frequency of external force matches the natural frequency of the body. If that happens, amplitude of the body is maximum, and this phenomena is known as resonance. And this is the condition, important condition for resonance to take place. That is, the frequency of external force equals the natural frequency of the body. Alright, thank you.